Okay, we start the new one. Okay, for this example, we have 4 element rate, and K1 is equal to 1000, K2 equal to 2000, K3 equal to 3000, K4 also equal to 4000. And the applied force P is applied at the node number 3. So according to this, if we form the element stiffness, for element number 1, it should be 1000 minus 1000 minus 1000 and also 1000, right? This, okay? In the same manner of K2, K3, and K4, we also have the same, in the same procedure like this. And I note that the element number 1 is connected with the node number 1 and node number 2. Element number 2 connected with the node number 2 and number 3, right? Element number 4 and number 3 connected with the node number 3 and 4. And element number 4 connected with the node number 4 and 5. Okay. After that, we can write the expanded form. After we write the expanded form and we sum up for the position that is in the same position, for example, for the element number 1, see that this position that is on the node number 2 and node number 2 also has another, for another element that is the element number 2, it has on the row on the node number 2 and number 2 also, and in the same manner as the for node number 3 and node number 4. Okay, so according to this, when we assembling these elements together, we will find that the total element stiffness should be like this. Okay, this is for U1, U2, U3, U4, and U5. Okay, for node 1, 2, 3, 4, 5, and for column also, this is for column number 1, number 2, number 3, number 4, number 5. Okay, and we have this element stiffness, global stiffness. This is we call the global element stiffness. And you will see that if you finding, I will ask you to input this metric into the MATLAB. You may input this metric into the MATLAB and finding the inverse of this metric and report me to on Thursday what happened when you would like to find the determinant or the inverse matrix of this element of this metric. What's happened? Okay, and you will see that this is the singular matrix and you cannot finding the inverse. Okay, and determinant of this matrix, it should be equal to 0. Okay, so according to this, we call it is the global stiffness without the applied boundary condition. For this case, it means that it has no support. So the system can move rigid body. It has the rigid body motion. It can move. It has any motion can be occur for this case. So in order to solve the solution, we have to apply boundary condition first. For this case, if we come back to the problem, we found that the boundary condition at node number 1 and node number 5 is fixed. So the displacement at node number 1 and node number 5, it should be 0. So for this case, we will cut off the first row. That is for the node number 1 and the 5th row of the node number 5. And also because it is the homogeneous boundary condition, we can cut off the first column and the fifth column. So according to this, we have only this. That is 3 by 3 matrix. This is 3 by 3 matrix. Just only this. So we get this matrix. Okay. And it's compatible with the displacement U2, U3, and U4 at each node. Okay. That is the force is applied at node number 3. Okay. So according to this, we can solve for U2, U3, and U4. Okay. So that's all for this example. So according to this, we can apply the MATLAB software to solve this unknown. Okay, to solve this unknown, we can apply MATLAB, or you may use your calculator to solve this value. Okay, for today, do you have any question?
ตรงเมทริกที่เป็นแรง500ครับเป็นลบเมทริกนั้นหรือว่าเป็นเท่ากับ
What do you mean?
ไอ้เมทริกของค่า k คูณกับเมทริก u ลบเมทริกของแรงเหรอครับ
Okay, we starting with the problem first. Okay, the problem we have the applied force at node number 3. Okay, and the applied force is to the right, that is in the positive sign convention. Positive sign convention is to the right. Okay, it's to the right. Okay, so it's positive sign convention. So after that, after we form the element, okay, so the force is force at node number 2. This is force at node number 3. This is force at node number 4. But force at node number 2 is no force. There are no force. So it is equal to 0, right? And node number 4 also, there is no force at node number 4. It should be 0, but we have the force at node number 3. It is 500. Okay. So do you understand?
ครับผม